Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve the next question number 27 of JEE Mains Physics paper 2016. So let us solve the question number 27. Students, let us solve the question number 27. It says the galvanometer having a coil resistance 100 ohm gives a full scale deflection when a current of 1 milliampere is passing through it. So, in case of a galvanometer, we know in case of a galvanometer, it has its own resistance of 100 ohm. It gives a full scale deflection of when the current is passing is 1 milliampere. This is the full scale deflection. That means if you send little more current, then also it will show that full scale deflection. That means it is little more than 1 milliampere, then also it will show the reading will show 1 milliampere because it has this limit. And if it is more very much higher than this value, the galvanometer will or might bar. So now what is the question? The value of the resistance which can convert this galvanometer into ammeter. So this particular instrument, which is called galvanometer, has certain limit that it can measure maximum current of maximum I it can measure in this situation is 1 milliampere. We generally call this as IG. The maximum current the galvanometer can measure without being converted to ammeter. So this is the original condition of this galvanometer, and that is 1 milliampere. That is the maximum value it can measure. Now we are not interested in this. We are interested in converting this galvanometer into ammeter because ammeter has greater range of current measurement, giving full scale deflection. Again, that instrument I want to convert this into something I'll do so that it can measure 10 ampere. Now from IG to certain maximum current, suppose I want this to measure 10 ampere current. So to move from 1 milliampere to 10 ampere, how many times are increasing the current? The current is increasing by, if I say n is the number of times the current has to be increased, the maximum current that can be measured is increased, is I divided by I over G, which is 10 divided by 10 ampere divided by 1 milliampere, which is 10 ampere divided by 1 milliampere is 10 raised to minus 3 ampere. So this amps cancels, this goes up, and this is 10 raised to 4, that is 10,000 times. If you want to convert the galvanometer into ammeter of range of this 10,000 times the current maximum current that has to be increased, then we have to have certain arrangement that we have already known. If I connect with this galvanometer, I connect low resistance in parallel, that is called shunt. If you shunt this with a small resistance, then this total arrangement, this new device that is formed here, this one galvanometer together with the shunt one is called this one is ammeter. This now is ammeter, and it has got better range of current measurement. And now it is we are interested in measuring this time 10 is to 4 times, that is 10,000 times much current than earlier 1 milliampere. If you can also check that if I multiply this with 1 milliampere, I'll get 10 amps. The range has to be increased by 10,000 times. So for that you require a specific resistance. So for what value of S, this we can move from this arrangement to this arrangement. So that is what you define. The value of resistance, that is the value of S, is asked, which can do this. So we know very well that in case of a galvanometer, if we have got these two are in parallel, the shunting is parallel connection, so the potential difference will be same. Now in this case, this 1 milliampere only has to pass through galvanometer, but main current that we want now here is 10 amps. 10 amps has to come from here. So 10 ampere that is coming through, and it measures here as 10 amps. Now earlier it was measuring 1 milliampere. So the rest of the current is to pass through this. Out of 10 amps, only 1 milliampere will pass through galvanometer as usual, because it has to, but the remaining will pass through this, but the potential difference will be equal. So I can take the potential difference equal and solve it. That is one way. Another way also I'll tell you, but this is general method. So the current that is passing through is 1 milliampere, and the remaining 10 minus 1, 10 amps, and 10 raised to minus 3, 10 raised to minus 3 amps will pass through this. This is 1 milliampere. That also I'll convert it into ampere. So the potential difference is same. So I can write Iz into G equals to I minus Ig into S. This is 1 milliampere. This is 100. This is 10 amps we want. This is 1 milliampere, and this is what is required. If I solve that, this is 10 raised to minus 3 amps into 100. This is 10 minus 10 raised to minus 3 and S. If you solve this, you'll get the answer. I can write this as 10 raised to 1 divided by 10 raised to 3. So it is 10 raised to 4 minus 1. 10 raised to 4 minus 1 divided by 10 raised to 3 S. Here it is 10 raised to minus 1. So it goes to this side. 10 raised to 2 is 10 raised to 4 minus 1 into S. So S is 100 divided by 10 raised to 4 minus 1. From here, 10 raised to 4 minus 1, if I don't see this one, neglect this one for the time being to see the options whether I'm getting. So I'll advise you that you don't take this one. Mentally you think that this is not there for easy calculation. If I do that, then it's approximately 100 divided by 10,000, then this is nearly equal to 0.01 ohm. And 0.01 is this one. This is the correct answer. So what I want to say is that even if we neglect this, because from 10,000 if 1 is subtracted, the number is still very large. It doesn't influence because this is in the denominator. So being the number in the denominator, it will hardly influence the shunt resistance. So therefore this you can solve like that. Another way is how quickly you can solve this. This is a formula for S is G divided by N minus 1. This formula you can use directly. That shunt resistance required is 100 ohm is the resistance of the galvanometer, divided by N we have calculated 10 raised to 4. So it's 10 raised to 4 minus 1. It's just like that only. So this way you can calculate very easily 0.01, considering this is neglected. So this is the answer to this question. The answer to this question is option number 1. Option number 1 is the correct answer. Okay, thank you.